let's thank again Konstantinos for his presentation. And are there any questions? Okay, if there are no question for the audience, I have some curiosity. First of all, I was wondering if the basic problem that you tackle with the greedy algorithm can be solved using some variation of the Martello thought heuristic, because it really looks like a multi-dimensional, multi-knapsack problem. So if your greedy algorithm is somehow inspired by this literature.
To be honest, I have to look into this method, but essentially what I want to do is not to do some heuristic. I want it, my result gives also a bound.
Okay.
And it's so in this aspect, it's not it's kind of predictable what result you will get. But yeah, I'm not familiar with this heuristic, so I cannot give a definite answer.
Okay, they basically try to sort all the incoming jobs based on the reward, and then they fit in the knapsack as long as there is space. So it's a greedy heuristic.
Oh, right. Okay. Yeah, I think okay. Now that you say, I think I know that. Maybe it's not applicable because I have multiple dimensions also in jobs.
Okay.
Single dimension. And if you think about it, the greedy part is on the configurations, which it's not that I try to fit one server, to fill one server. I try to fill configurations in servers.
Okay. And another. Okay. There is a question from Raul Vase. So please.
Yeah. Hi, Ricardo. Hi, Konstantinos.
Hi.
An interesting problem. So I just wanted to understand, maybe I missed it. What is the packing constraint on a server? When you say a certain type of jobs are allowed to be executed simultaneously on the server, how do you define that?
Actually, the way I model it's hidden, the packing constraint, but yeah, essentially every job has multiple dimensions with certain resource. So the sum of resources have to be less than the resource of the server. This is hidden because I just mentioned in the model which configurations are possible.
So it's just a size constraint in some sense?
Size constraint, yeah.
Okay. So one can think of it as a bin packing problem with a size of the bin being given ahead of time, also the number of bins given ahead of time. And then you're trying to minimize the total time by which all of them are processed?
This is possible. Here, my bin size is fixed, and I also have multiple dimensions in the bin. So the bin doesn't have a single size. It may have, let's say, CPU and memory, if we talk about servers.
Yeah, it's a multi-dimensional bin. So you can think of it as a... But they're kind of box constraint in some sense. Right? So with each bin, it's a rectangle. You can think the multi-dimensional rectangle constraint is what we are looking at.
Right, you can model it as a constraint like that.
Yeah. And then finally, for the greedy algorithm, what is the guarantee that you get?
Which greedy?
So the algorithm you defined has greedy components to it. What is the final guarantee does one get from this, that in approximation?
So my approximation was 1/2 was for any case. Minus 1 over E is what it's kind of not proven for every case, but I think that's a general case. I wasn't able to prove it. I was able to prove it only for a subset of the space, the 1 minus 1 over E. And I haven't found a counterexample. That's something I didn't mention. I haven't found a counterexample that is worse than 1 minus 1 over E, than this approximation factor.
So I think, as Ricardo was asking,
sorry to interrupt, but I think we are somehow running low on time. And if there is time, there is an additional question on Slack from Carrie Williamson about some characteristic of the Google traces. I really don't know if you can squeeze a fast response to this question, or if you can.
Oh, me? Yeah, I can answer the question, which is really good. Actually, my bound is upper bound. Yeah, it uses future knowledge, and it's not really feasible. Maybe this bound that I show in the graph is not feasible. It's like it can take a job back, a job that it rejected in previous. It's as if you can take it back and solve the optimal again, which is not possible for any algorithm.
Thank you.
Okay, one very final question from Danilo Ardagna about how you compute the optimal bound and if there are penalties related to the preemption.
I don't have penalties for the preemption. That's why I'm saying it should be considered per case. For the optimal bound is, it can be solved like from the optimization problem that I showed in the first slide. That is hard to solve. If I solve it, I found the bound from there.
Okay, thank you.
Okay.
Thank you.
So thank you very much for your answer. Congratulations for your award. I think we can move to the next paper.